Next, we have our technical keynote. It is such an honor to welcome to the stage to present on the impact of the factory of the future, Mr. Blake Moret, who is the CEO and chairman of Rockwell Technologies. It is such an honor to have him at our conference. And while he's making his way to the stage, I will just point out a few people have asked for the Wi-Fi password. Look for the Wi-Fi network Fairmont meeting, and the Wi-Fi password, which is on everybody's tables, is MF 2018. So now we all have Wi-Fi. Anyway, please welcome to the stage Blake, the CEO of Rockwell Technologies, Rockwell Automation. Thank you. Thank you so much. Absolutely, yeah. If you're good
with that. So I'll be the interlude between the initial remarks from the panel and then the Q&A this afternoon. The remarks I'm going to make now are largely from a presentation that I made to the Mechanical Engineering School at Georgia Tech a couple of months ago, which in turn was essentially a do-over from a paper I had submitted to the American Society of Mechanical Engineers in 1987 when I had just graduated from Georgia Tech. And that paper was not great at that time, and so I had the unique opportunity to do a do-over 30 years later. So that paper was to talk about what things might come true in the world of automation, and I got some things right, and I missed some other things completely. So this is a few comments, and then in the context of the discussion today, some of the things that I think are going to be really important going forward. So I have worked my whole career with Rockwell Automation. I accepted a job with the then independent Allen Bradley Company based out of Milwaukee, Wisconsin. And by the time I showed up for work, they had been purchased by the conglomerate Rockwell International, which was doing things like the B-1 bomber and the space shuttle at that time. It's taken a while, but essentially Allen Bradley has completed the takeover of Rockwell International. What remains of Rockwell Automation is the original Allen Bradley company, and we're bigger, but it's still all about factory automation and more recently using the information that is a byproduct of those manufacturing processes to make companies more productive. And that's what we do. It's all about industrial productivity, period. And a comment as we talk about the importance of what's being discussed today. When I started working for this company, as a 20-something-year-old freshly minted engineer, I wanted to find something that was bigger than the paycheck in terms of giving me a bond and feeling that what I was doing was important. My wife is an RN, and she worked in labor and delivery, and so it was pretty easy for her to make the connection between what she did and a higher purpose. And it really was about strengthening what I believed and what I still believe is the vital core of the American economy, manufacturing. There's so much of an amplification, and all of you have the numbers in mind better than me about how much is at stake for strengthening a manufacturing economy. So some of the trends, a quick tour of those. The thesis that the rise of the middle class around the world will drive demand for made stuff, I think, is still intact. So that's good news. As hundreds of millions of people now have the economic power to be able to have a wider choice in food, to be able to have clean drinking water, to be able to buy pharmaceuticals that help them live longer and healthier lives, that's driving demand. And it's distributed around the world, and that in part, I think, has driven the flows of manufacturing footprint around, as well as the ideas about things like wage arbitrage and so on. With it, and acutely in the U.S., and Andre and others talked about this, is the skills gap. And for the first time, it's not just something that we're talking about is coming. We are seeing it as a part of the critical decision path for manufacturers to decide whether they can start a major project here. It is upon us, and it is something that took a long time to get to, and it's not going to be solved overnight, but it is the existential threat to the manufacturing economy. Supply chains, they're complex, they're worldwide, and they bring the increased requirements of software to complement hard tech. So there's a manufacturing process, and then there's the ability to be able to pull from the best and the most competitive around the world to be able to bring it together. And so it requires a certain agility, a certain nimbleness that is difficult to do, but it also levels the playing field. It takes the game away from that of raw scale and allows small and medium-sized companies to be able to get to a competitive position much more quickly. The mass customization, moving towards a batch side of one, again, puts additional emphasis on the requirements for software, scheduling software, manufacturing execution software, linkages with ERP systems to give the flexibility, to be able to optimize the sequencing of production, to be able to reduce setup time. Because after the avoidance of unplanned downtime, the reduction of setup time is probably the easiest equation to solve in manufacturing. You know what your downtime is, and you can turn it into an ROI pretty quickly. Workflow optimization is another important aspect of this, because you saw Willie show the plant, the glass plant, and that is one of the very far-end examples of automation and reduction of labor. The status quo in plants today still has a lot of people. There are still a lot of people even in advanced competitive facilities, and so the interaction of people with that advanced technology and to make them as efficient as possible, to be able to do the error proofing, to incorporate the ergonomic design so that they don't get tired and restless. In fact, at that Toyota Georgetown plant, which is just an amazing facility, they're doing ergonomic research at a scale that would really surprise you in terms of understanding how people respond and how to get the most out of humans, which is still an important part of this equation. Manufacturers are doing a tremendous amount of the research, but as has been talked about this morning, it's in a diffuse way. And harnessing that and bringing it together, being able to share capacity with small and medium-sized manufacturers is something that I've been hearing about ever since I was part of the Manufacturing Institute that within the National Association of Manufacturers. So making that computing power ubiquitous, and we're starting to get there, but I think that's an important part of it. Again, to be able to couple the innovation that comes with those fresh companies with the necessary resources to be spun up quickly. So countries all around the world recognize that there's something here and that it's important for a public-private partnership to move this forward. We see China Manufacturing 2025. We see Make in India. We see Industry 4.0. The U.S. has some initiatives, but I don't think we've coalesced in the same way around this recognition. And as the common theme of the morning, so much of the innovation comes from right here, but we're not putting it to work at the pace that we need to. The Rockwell approach is a pragmatic one. It starts with the smart devices that generate the data that are required for the fundamental control, and then it takes it into the technology stack to be able to turn that data into useful information to provide a higher order of productivity. So for the last 30 or 40 years, a lot of the automation and the productivity gains have been replacing the purely repetitive physical labor with programmable control and computer numerical control and robotics. To be able to get to that next order of productivity, it's all about taking the data that's a natural byproduct of those fundamental processes and turning it into the insights through analytic processes to be able to predict the downtime and to do something about it before the bad thing happens, to be able to optimize the throughput, to balance loads on systems to avoid hitting energy peaks. And so that's where a lot of the game is today. Again, it's that marriage of the control technology, the OT technology, the hard tech with the IT, and it's happening right now. You still have to understand the processes. The technology alone won't save you. You have to understand how to apply it. So the IT folks with their big budgets in these plants come down, but they have to work together with the people who actually know the processes. Because as most of you know, having clean data and work processes that can be quantified and that are accurate, that aren't full of art that came with the specific person on the line, is one of the biggest enemies of automating these processes in a meaningful way. And so you have to have both. It has to be applied to specific industries. This is an example of oil and gas where things like monitoring big rotating assets, looking at flow and temperature and pressure, those are the important things there. When you apply this technology into an automobile assembly line, the value drivers are different. The building blocks can be the same, but the places where you do your computing and your data storage and the assets that you're actually monitoring and controlling, those change, and you have to understand something about the specific context to get the most out of it. It's scalable. So different industries require different size data sets, different computing surfaces, different security demands. Security, when you talk to customers, when you talk to the operators, it's the first and the last question. And it's a defense in depth kind of discussion. So it's at the end device, it's at the communication, it's at the storage, it's at the personnel practices to make sure that you're not getting sloppy and that it's being shared on a need-to-know basis. So it's a wide attack surface, and most of the breaches are pretty lowbrow things. There is a wide variety of technologies. Obviously, if we work from right to left, the things on the right being the things that people are accepting and they're being put to work, I think the cloud is there. When you're having to deal with large data sets, when you are comfortable that you can move data outside of your firewalls, there's lots of applications for enterprise-wide applications. Asset management and the trough of disillusionment. People have been trying to buy work order platforms to make their maintenance processes more simple for a long, long time. The fundamental problem is that you don't put the right data into them, and so all of the neat things that could come from training those models don't work because the last time the line went down, you didn't characterize what caused the problem. Machine learning, artificial intelligence, and the peak of inflated expectations. Try to buy an AI company today, and it's a profit, no need. It's certainly, there's a lot of excitement about it in the manufacturing world. The fact is that there's not a tremendous amount that's being installed today. There will be. It's going to come. Time will tell whether it's as big as the expectations currently. And then at the very front end, things like augmented reality. Again, you can see a demo in almost every booth at a trade show, and they're interesting use cases. People aren't quite yet putting money into the actual end application. The money that's changing hands is basically companies buying and selling each other at this point, and funding the startups. I thought it was an interesting comment that a lot of the VC money is fleeing hard tech, and it's all going to AI and communications technologies and other IoT concepts. I don't know that that's a good thing. Again, the technology, the raw capabilities are there in a wide variety of areas. This is just a sample of some of the human functions that can be automated, and in pretty much all of them, it's either there with machinery and software being able to do a superior job to the average person, but it's the question about automating. It's a question about working that into the overall process, which still requires people. Parts of jobs are typically automatable. There's not a whole lot of jobs in manufacturing and companies that are still competitive that can be completely automated, and that's good news, because addressing that with concepts like cross-training for people to be able to work in multiple areas, the idea of lifelong learning to make sure that what you invested a week of training in for a person when they were 23 isn't what's going to have to sustain them for the rest of a 40-year career. It's a basic concept, but companies underfund their commitment to training middle and even later stage career workers, and you have to do it. You don't just get it by osmosis. So, and workforce is, as I mentioned before, it's a big deal to our industry. It's a big deal to me personally as well. And I think, and these again are some concepts that were developed working with the Manufacturing Institute a few years back, and as I've had them tested, I think they still hold up as some fundamental requirements in order to have a trained and engaged workforce. It is that concept of lifelong learning. It's instruction that's outcome-based. A one-size-fits-all class where you have experts and novices in the same class and it's lecture the whole time with no hands-on and no practical application, that ground is going to get saturated really quickly. It's just not going to be enough to retain that information. And then the theme of what we're talking about today, really the partnerships between learning centers, whatever they are, and the manufacturers, so you can couple the demand with what's being provided. You know, at the end of the day, whether it's training for a technician job on the floor or it's what we do, there's kind of three things, again, that are important to us through our careers. First of all, we want to know that it's important. We want to know that we have the tools and the support to be able to do a good job, and we want to know that we have an opportunity for advancement. And I think that can be applied to most of the things that people do for a living. We stood up something about 6 months ago, a little bit longer than that, to train returning veterans for factory jobs. The target is the technician level skills, and we looked at the main occupational specialties, the MOSs of returning veterans, working with manpower to wire the supply of all these veterans coming out of service with jobs that could be a good fit with their basic fundamental knowledge. Most of them have high school degrees, not more. And then in a 12-week course, to be able to give them the hands-on training so that they can successfully move to good-paying jobs. Typically, they're moving into technician-level jobs, paying over $70,000 a year. We'll graduate about 150 by the end of this calendar year, and we're going to scale up to being able to move 1,000 a year through the program. And it's the intention is for 100% of them to be able to work either for our customers, for the people who use this technology, or we hire them as well. So that's it's working. I'll show you a short video on this.
The interesting part about this program, the Academy of Advanced Manufacturing, is it's filling a void in the manufacturing world. We're filling a skills gap. We're employing men and women who sacrifice for the country.
Where we're partnering with Rockwell Automation, which brings their fantastic engineering training program to bear, and Manpower Group is bringing our ability to source and recruit, assess, and provide professional skills training for these veterans.
We're going to take people that on day one had some understanding and technical capability because they did some incredibly technical roles in the military, that over the course of the 12 weeks will learn to be pretty darn close to experts in automation and advanced manufacturing.
I was in the Army. I was a 14 Tango, which is a Patriot Air Defense Artillery. I get a call from Manpower Group. They have this program for veterans. They were really excited. I was really excited. And I said, hey, you know what? This program seems like it was made just for me. It's in industrial automation and controls, which is something I've always wanted to do, but I was never able to get into it.
From day one to now is totally different as far as my knowledge base. I had zero knowledge on anything to do with automation.
This program has given us a huge jump start. They've essentially taken 4, 5, 6 months of training and compressed them into 3.
We're going out to customers and sharing with them the story of the program. And they come back a few weeks later for placement days where they get the opportunity to sit down with those candidates, interview them, and make hiring decisions.
Everything that I've learned from this program has been in line with what the companies are looking for, and I'm confident that I'll fit right in, and I'm confident in my skills of what I've learned.
To be able to go into a company and say, okay, tell me how your processes work, tell me what we can do to help you make it better, tell me what we can do to leverage things like Connected Enterprise to really take your business to the next level. That's really what I want to do long term.
I felt a sense of pride, and more importantly for me, like being useful to somebody.
It was a door that opened to basically a new part of my professional career.
Just accepted an offer with a paper manufacturer to be a process optimization specialist. And all of the things that we covered, I'll be doing on a day-to-day basis.
I'm proud to be in this program as a veteran, as it shows other veterans out there that there are possibilities.
When I came in here, I was like, nah, I'm just a guy in the background. I had to see in me what other people were seeing.
This is a springboard to the rest of my professional life.
The biggest question that we got when the veterans showed up was, is this real? Is this because they were convinced that it was going to be a scam at the end of the day, and we're going to ask them to buy something or whatever. But that was really something that we learned. And what a lot of these people begin to recognize is how powerful they are in the organization that they're going to work for. That technician level job is so important to the heart of these businesses, and I think that's part of our challenge is for high school kids to recognize that this is a path, and it's not it's not the only goal that matters to go into a 4-year university. There's certainly a need for that as well, but to recognize that if you want to take a different path, or if your life circumstances require you to take a different path, there's some options that are extremely powerful and can be lucrative. So, and just to wrap it up, and then I have a few minutes for questions. it again is about the convergence of IT and OT, and both are going to be necessary in the outcome, and it's going to require that combination of the technologies that for years have been used in the carpeted part of the enterprise and bringing it together with the know-how that often lives in the part that's a concrete slab on the floor. So with that, happy to take some questions.